Hello everybody, in this lecture we are going to prove the following statement. Let M be a module. The submodule S is a direct summand of M if and only if there is a retraction P from M to S. Now for the proof, one direction is obvious, and the obvious direction is if M is a direct sum of modules S and T, all we need to do to get a retraction from M to S is look at the projection. So P from the direct sum of S and T to S is a retraction. So this direction is clear. If M is a direct sum, there is a retraction from M to S. So the only thing we really need to show is that, assuming that there is a retraction from M to S, M can be written as a direct sum where S is a direct summand. So assume we have our module M, and we have a retraction from M to S. Let's call this P again. And what we are going to show is that we can express M as a direct sum of S and the kernel of P. So what we are going to show is M is isomorphic to a direct sum S plus the kernel of P. To show this, look at an arbitrary element, small m of M. So this M is in big M. And we can write it as M minus Pm plus Pm, thereby just adding 0. And now look at MPM. If you apply P to MPM, you get P of MPM, which is equal to PM minus PPM. And this is 0 because P of M is in the image of P, obviously, which is S. So PM is in S. And if you apply P to an element of S, you get the identity. So P of PM is the same as PM. So this is 0. And PM, this PM, is an S by what we just said. So we can write M as a sum of elements in the kernel. This first element is in the kernel, and the second element is in S, which is the image of S. So all we need to show now is that this way to express M is unique, which means we have to show that the intersection of S and the kernel of P is just the 0 element. So assume we have an element, let's call it M bar, which is in the intersection of S and the kernel of P. Since M bar is in S, we have P of M bar is M bar, because P is the identity on S. And since M bar is in the kernel of P, we have P M bar is equal to 0. And combining these two equations, we get that m bar is equal to 0. So the only element that is in the intersection of S and the kernel of P is the 0 element, and we have indeed that M is a direct sum of S and the kernel of P, which is what we wanted to show. And this concludes the proof of this statement. Thank you for watching. See you next time.